Hey, what's up, you amazing hackers? Hope you're all doing well today. Get a little bit in the Christmas spirit, I would say, with this, the hidden SQL injection techniques that Google doesn't want you to know about. Ooh, scary. So there's a GitHub repository to this as well. It's just a link to the SQL map project with the installation command as well added to it, and also how to get started with SQL Map. So SQL Map offers various parameters and options to customize your testing approach. Let's dive into some essential commands and techniques. First of all, crawling the website. Crawling is the process of traversing a website to collect information. SQL Map allows you to crawl a website with different depths. So if I find a website, google.com, and I find a link on it, I can follow that link. I can follow these links that I find. That is what's crawling. That is what's considered as crawling. We set the depth of aka how many links can it follow. Like, for example, if it follows a link, there it might find another link that is too depth, so too deep. And then as you go with another link, you go to level 3, and you can basically set it up how much this is allowed to crawl with the -- crawl command. We can also streamline this with batch mode. This can save time by automating responses as well. And we can also multi-thread this for efficiency. Multi-threading is just boosting your efficiency by using multiple threads. Using this command, we can control the thread number depending on our internet speed, CPU and GPU speed, and server response. What he's trying to say there is, of course, if we have enough threads available to our CPU and a GPU and enough internet speed, we can increase the number of threads through multi-threading to speed up this whole process. You can see, and the advice given here is to always start with one thread, gradually increasing the number, monitoring for errors or crashes. Using up to 10 threads is generally okay for small to medium sites, but go higher with caution, and there it already comes above a little bit. You don't want to, you only base this number based on your CPU and GPU threads available. You want to base this number based also on what your target can handle. For high-profile sites, very large databases, or critical infrastructure, stick to a minimum of threads, somewhere around 1 to 3. I don't know if I particularly agree with this. What I would say here is please check your target, because they may have specific rules written out for this. It is very important that you don't use too many threads here, that you go very, very slow. I like that advice, but I don't see a minimum or a general setting that is okay for everybody. It just doesn't exist. Everything's going to have to be very custom tailored to your target. But I do get the sentiment here. In general, smaller websites can handle less threads, of course. You can also add the risk level. The risk level uses different harmful payloads. Risk level 1 is good for initial testing. 2 to 3 is moderately aggressive and only use level 4 to 5 risk payloads against local test systems. For critical infrastructure, stick to 1 or 2 during the assessment, and if using risk 3 to 5, monitor closely for application server errors, hangs, crashes, etc. Again, partially true, don't fully agree with this. In general, level 2 is pretty safe to use, even for the initiation of the testing. That is also, if I'm not mistaken, the base risk level. 3 would also be pretty acceptable for most cases, but if you want to go beyond that, I always say that you need to have explicit permission for that. And it's not per se just the risk level of the payloads. Like you could say, for example, if it goes to risk 5, is it suddenly going to start dropping tables? No, that's not how it works. It's basically just how advanced of a payload am I willing to try that carries different risks with it. For example, I could send in a timeout, and that timeout could only be for my thread, where I just time out the server for me and nobody else. That's less risky than if I try to send out the timeout that's going to time out the server for everybody. That's what those risk levels are, but do look into it. Then you can also select different SQL injection techniques. SQL map supports various techniques, such as the union technique. This command is used for the union technique below dash dash technique equals U. The union technique is where it's going to have the original query, it's going to add another query on top of it, and it's going to try to put a union in to get those two queries together. And then if it does get the result of that second query in the response, then it knows that the union has worked. Pretty interesting technique here. You can also add verbose mode. SQL map provides detailed output, including payloads and HTTPS request error messages. We can retrieve database information with the dash dash current user dash dash current dash DB and a dash dash hostname. We can also grab that. Of course, if there is a potential for the SQL injection, what might often happen is that there might be some type of filtering in place as well, that for some of these attack vectors, for example, a very simple union string might work, but the moment you try more and you try to get the current user, the current database, or the host name, it might block you either ingress, incoming traffic, or egress, blocking outgoing traffic. It's important to know this because that is where the real tricks to SQL map lay, in my opinion. You need to be able to also subvert these filters and WAFs, because of course just attacking a WAF is something that is already pretty difficult in and of itself. If you're going to add automated tools to the mix, then it becomes for most people pretty much impossible, which is very normal. But you can play around a little bit with SQL map, or you can even add your own proxy. What I would do is I would put SQL map up, okay, listen up, and then I would put a proxy up that I've written in Python. I would put SQL map through my proxy, and with my Python proxy, I would remove or replace any infracting characters on the go. So if a request is being sent from SQL map and that request contains a percentage sign, I am going to use the HTML entities encoding for that with my proxy and replace everything in the request and send it onwards to the server. That is a good way to do that, because then you can test which things are not allowed and you can try what can get around them. So you can try to set up your own proxy that's going to subvert this WAF. You can do this for any tool basically as well. Don't think this is just limited to SQL map, but it's just a good example. You can also explore the database structures, listing them with dash dash DBs, or exploring the tables in a specific database with the dash dash tables. But you do have to add the dash D database name to that. Extracting data is also possible. You need to add a table. The table name needs to be in there, and you need to add the dash dash dump to the command. So dash T table name dash dash dump. Viewing table columns is also possible, of course. You just replace that dash dash dump with dash dash columns. And you can also dump all data, just adding the table name and the dash dash dump all command with it. There's also a custom output directory that you can use if you want to. That is the SQL map output directory. You can add the dash dash output dir there, and you usually use that indeed with the batch command, because that's going to generate quite a lot of output. And if you want to have a specific output directory, not the one that SQL map is currently being executed from, then you add that to it. Some advanced usages here is manipulating headers and user agents. Now, why would you add custom headers, do you think, for authentication, for example? That could be a good one. There are more use cases, but crawling authenticated SQL map injection is often better. And how does authentication happen? through the headers. And you might be saying here, Uncle Red, a cookie, what the hell with that? How do I add a cookie? A cookie is just a header, my friends. So you can add that cookie with the dash dash headers command, but you can also add things like a bearer token there. You can modify the user agents as well with the dash dash user dash agent equals. Sometimes that will get by some WAFs and stuff like that. Or you can use a mobile user agent with the dash dash mobile, because sometimes the request will be processed differently based on mobile or a desktop target. Some advanced tips here are using a mobile as user agent or a real browser user agent like Chrome or Firefox make the requests look more legitimate and less suspicious. That is one of those things that a firewall could, for example, try to block you on. You could try to add a header from a normal browser or a mobile browser, and that might bypass some things, but also, of course, the APIs might respond differently to those mobile headers. Many firewalls block requests from common SQL map user agents. Setting a custom user agent can bypass the firewall. As for bypassing firewalls specifically, we can also use the tamper command with the, first of all, list tamper command, dash dash list tamper. So that is how we can encrypt things, for example. Like, for example, base 64 encoder, which will try to bypass certain things by doing a base 64 encoding of the text string. What I don't like about this is that it's going to tamper with the entire text string. I don't like that because sometimes only one thing is blocked, and to tamper with your text string just because of that one thing is sometimes going to make it so your entire text string doesn't work anymore. So that is why I said use that proxy example. Learn how to write your own Python proxy, for fuck's sake, it's not that hard. I have one also on my own GitHub, so I'll show that maybe later, but it's super simple basically. Some advanced tips: WAFs slash firewalls blocking based on payload keywords. Use common tampers like dash dash comment equals n to disrupt keyword blocking rules. Replace spaces with comments via the space to MySQL dash or tabs via tabify spaces. Use the versioned more keywords tamper to add version strings to keywords like select slash exclamation mark 00000 ver equals and then a version. And you can have WAF slash firewall blocking specific characters like the base 64 encoding, Karen code, car Unicode decode. Jesus. Also, you can use a backslash quote or apostrophe mask. Jesus Christ. To sneak quotes slash apostrophes past filters. Replace equals with like via equals to like tamper to bypass equals blocking rules. Payload size limits can use between tamper to split payloads into random chunks. You can also do that. Reduce inline comment size with comment inline tamper, definitely possible as well. And replace these spaces with small comments like slash star star slash via space to comment. Brute forcing the login pages. To test for SQL injection in login pages, follow these steps. Here are the typical steps to brute force a login page using SQL map. Manually analyze the page to determine the key parameters, identifying username and password fields and noting their HTML name attributes. So just inspecting the page, finding which form fields are responsible. We will have to do this in a post request, so we'll have to indicate that later on. Finding the form submit button and getting its name attribute, and checking the form's action attribute to see where it submits to. Together that makes SQL map -u, and that is just that login endpoint. That is that last one, the form action attribute. -- forms to indicate that we are working with a form here. --crawl equals 2 to indicate that we can go too deep when we find a link. --batch to do this in batch processing with --threads equals 5 for 5 threads. We also need to give those fields, of course. So we do -p and then we add our username equals and you add the asterisk there to make sure that it indicates where it can inject. Ampersand password equals asterisk, ampersand submit equals submit. He's going to go on level 5. We haven't looked at that yet. And risk 3 with a dash v at 3. If we look at just that level, we see that we have that aggressive testing. Remember, we have that risk. So the risk level, depending on the dangerousness of the payloads, the level is the aggressiveness of testing, similar but not very true, not exactly the same. We'll go more into that later. And we set the verbose level to 3 for more detailed output. We also have some advanced options like those cookies. We can add them separately, but we can add them in a header as well. The session management, because we can flush sessions if we want to. We can uncover hidden comments. Sometimes you might find a comment in a SQL statement or whatever. Accessing the command shell is also possible sometimes, not always of course, with the --os shell command there. So SQL injection testing with SQL map is a powerful way to secure your web applications. Remember to use this tool responsibly and only on systems you have permission to test. Stay safe and happy hacking. I'm not gonna lie, Mahmoud, this does sound like it's pretty much written by ChatGPT with a few corrections from you. There's nothing wrong with that. But here's a few tips. ChatGPT always ends with a conclusion like this. So if you like, that's something I'm not sure. I'm not 100% sure, but I'm like 90% sure that a lot of this has been written by ChatGPT. Also because there are quite a few things, quite a few extra tips that could be in here. We've tried to go through a lot of it, but so far so good. The thing is, if you guys do this, just never rely on ChatGPT to give you a list of payloads, please, because that thing, it will literally give you a drop table statement and you really don't want to do that. Anyway, great article on SQL map. What is important here is that a lot of these things have been brought together into one article. So this is a good checklist if you do have some SQL injection testing that you need to get done with SQL map. What's missing here from me is a specific emphasis on that post testing. So testing actual, not just a login form, but testing like a search field, or testing like the changing of your password, or testing things like, well, there's quite a few things that you can test that are not just gets, and also the difference between that authenticated versus non-authenticated testing is something I think we should be hammering on very specifically. Anyway, I hope you guys liked this article. If you do, please do me a favor. Go to the link in the description below. Click that clap button and go and give this amazing hacker a follow. And I'll see you in the next one. Please don't forget to like, comment, and subscribe. And if you don't see you anymore, happy Christmas, amazing hacker.